Section 2.6, Solving Inequalities. An inequality is any mathematical statement containing less than or equal to, greater than or equal to, or is not equal to. A solution of an inequality is any value of the variable that makes the inequality true. To solve an inequality is to find all of its solutions. Is 2 a solution to negative 4x plus 7 is less than 3? Well, if it's a solution, then if we substitute it into the equation, we should get a true statement. So we substitute 2 into this equation. We get negative 8 plus 7. Is that less than 3? So that's negative 1. Is that less than 3? Yes, it is. It's a solution to the inequality. Let's graph these on a number line. X is greater than or equal to negative 1. It can be equal to negative 1, so we're going to put a dot at negative 1, and we're going to make it solid. We're going to color it in so that we can show that negative 1 is part of the solution. X is greater than negative 1 has to be to the right. And we're going to draw an arrow and kind of shade it in to show that the solution keeps on going in that direction. Y is less than 3.5. Now we have to locate 3.5. It's halfway between positive 3 and positive 4. This time we don't want to include the 3.5. It's got to be less than. It can't be equal to it. So we'll use a hollow circle to show that it's less than 3.5, but not equal to it. And we'll shade to the left, and we'll shade an arrow. This time x is between negative 4, can't be equal to negative 4, so we'll use a hollow circle. It's less than or equal to 0, we'll use a solid circle. And it can be anywhere in between those two values. So we'll shade them in. Properties of inequalities. For any real numbers a, b, and c, if a is less than b, then a plus c is less than b plus c, which simply means you can add the same number to both sides of an inequality to solve it. And AC is less than BC if C is positive. AC is greater than BC if C is negative. All that means is you have A is less than B. Notice if you multiply by a positive number, we start off with A is less than B. And if you multiply by a positive number, call it C, then your inequality stays going in the same direction. AC is less than AB. That's when C is positive. C is greater than 0. Suppose you multiply both sides by a negative number. Let's call it C again. Then you would have AC and BC. But if C is less than 0, if you multiply both sides by a negative number, the inequality is going to change direction. And that works for greater than, less than or equal to, or greater than or equal to. So, we solve inequalities similarly to solving equations, except that we reverse the inequality whenever we multiply or divide both sides of the inequality by a negative number. I'm going to refer to it as a bell ringing. Maybe you can hear my wind chimes. Whenever I multiply or divide by a negative number, it's as though I hear a bell ringing saying, wait a minute, we just multiplied or divided by a negative number. Doesn't that mean something? Yes, it means that you have to reverse the direction of the inequality. So we divide both sides by a negative 7, and we get x. We just divided by a negative 7, so we have a negative 4 over here. When you multiply or divide by a negative 7, you have to reverse the direction of the inequality. So our solution then is 4 and anything less than 4. Look at this one. Negative x divided by 3 is less than negative 1. I don't want that negative there, and I don't want that 3 there. What happens if I multiply both sides by a negative 3? Well, for one thing, the 3's cancel, but also the negatives cancel. So that just gives me then x, and on the right I have a positive 3. What direction does my inequality go now? Since I multiplied by a negative 3, it has to reverse. So x is greater than 3, can't be equal to it. So it's anything greater than 3. Let's solve. Negative 26 minus 16z is less than 6. So we're going to add and subtract before we multiply or divide. Let's add 26 to both sides. That doesn't do anything. It just makes it negative 16z less than 32. And now we're going to divide by negative 16. Ding, ding, ding. My bell rings and I think, wait a minute, I just divided by a negative. That means I have to reverse the direction of the inequality. So my solution is z is less than negative 2. Let's solve this problem. We have lots of parentheses. Let's eliminate the parentheses. 3 times 4 is 12. Minus 3 times a negative 3 is minus 9x. Greater than or equal to 6x minus 18. There are many different ways to solve this problem. The way I'm going to do it is subtract 6x from both sides, subtract 12 from both sides. That gives me minus 15x on the left. It gives me all my x terms on the left and all my number terms on the right. So I have a negative 30. I don't want that minus 15 there. I divide by a minus 15. Ding, 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 ding. I just divided by a negative. That means I need to reverse the direction of the inequality. It's now less than or equal to a positive 2. And that is my solution. James needed to buy 5 ties for his new job. He has budgeted for an average price of $15 per tie. James bought 2 ties on sale for $5.50 each, a designer tie that he really liked for $38, and a Christmas tie for $12.50. How much can he spend on his last tie and stay within his budget? Well, let's see. He needed to buy 5 ties. He has budgeted an average price of $15 per tie. How do you calculate average? You want to add up all the ties. Another way to say add them all up is a capital sigma. It means add up all the ties, sum the ties, and divide by however many ties you have, which is 5. So we're going to sum up all those ties. He bought 2 ties for $5.50 each. So $5.50 plus $5.50. Oh, he bought that $38 tie. And he bought the Christmas tie for $12.50. And he has one more tie. So we've summed up all the ties. And now we need to divide by 5, the number of ties that we have. His budget is $15 per tie, so he has to stay less than or equal to 15 to stay within his budget. So this is our inequality that we want to solve. I think we should multiply by 5 first. And if we multiply by 5, we can cancel the 5's over here. And let's go ahead while we're at it and add up all those things. We have $5.50 plus $5.50 plus 38 plus $12.50. That's going to give us $61.50 plus our x, and that has to stay less than or equal to $75. Well, what are we going to do now? Let's subtract 6150 from both sides. So we have 75 minus 6150. That gives us $13.50. That's how much we can spend on the last tie. I think we're going to be sorry before it's all over with that we spent $38 on that designer tie, especially after we spill something on it the first time we wear it. Mr. Jenkins runs an entertainment center in the summer with miniature golf, frisbee golf, and an arcade. He knows that he spends $48 a day for maintenance on the facility, electricity, water, lawn care, etc. It also costs him $56.50 a day for each employee that he hires. How many employees can he afford to hire if he wants to spend no more than $250 a day of expenses? So he wants to spend no more than, so he wants to spend less than, he's willing to spend $250, but no more than that. So it's less than or equal to $250. He spends $48 a day for maintenance, and he spends $56.50 a day for each employee. Let's call that X. So this is our relationship. We want this 48 plus 5650x to be less than 250. We need to solve for x. Let's subtract 48 from both sides. That gives us 5650. X is less than or equal to 202. Now we need to eliminate that 5650. And that gives us that x is less than or equal to 202 divided by 5650. 3.575. 3.575. Well, how many employees can he hire? He can hire 3 for sure. What about that 0.575? Do we want to round this to the nearest employee? He can't hire 4. If we rounded 3.575, that would give us 4, and he cannot hire 4. He can't afford them. So it has to be less than or equal to, let's just leave it at 3.575, so that he will know that maybe he can hire somebody half-time. He can hire his 3 full-time employees and 1 half-time employee. A health club offers 2 payment plans. One plan charges $700 yearly membership fee, which allows the customer to use the facility as often as he or she would like. The second plan requires the customer to pay $5 a month for membership and $8 each time he or she uses the facility. How many times would the customer have to use the facility in a year for the yearly rate to be a better deal? So he's going to pay $5 a month. So we're comparing it to a yearly rate. So that would be 5 times 12. That will be $60 in monthly fees, plus 8 times every time he uses it. And we want to know, when is the yearly rate a better deal? Well, we're comparing this to the yearly rate. And if the yearly rate is a better deal, then our monthly charge will be larger than our yearly rate. So we're trying to find out how many times he has to go before the monthly rate is larger than the $700 yearly fee. So the yearly fee would then be a better deal. Let's subtract 60 from both sides and divide by 8. X is greater than 80. So if he or she goes exactly 80 times then the monthly rate and the yearly rate will be exactly the same. But if they go 81 times, then the yearly rate is a better deal. And that's all for this section.